So what I want you to do is write what I'm about to write on the whiteboard on another sheet of paper, on the back of your semi-guided notes, if you have space on your semi-guided notes somewhere. It's just a quick review. All right. So let me take this off, clear canvas. We're going to call this applying transformations to graphs of functions. All right. Let's say you have this standard looking equation right here. F of x equals a times bx minus h to the nth power plus k. Of course, all of these letters will represent something, either x or the other numbers like a, b, h, n, and k will represent some number. All right. Y'all know I like my table, so let's create a table. All right. I don't know about term. Let's not do term. Hold on. Give me for that. Let's just say letter right now. All right. And then transformation. You're going to tell me what would happen. All right. Or what is the type of transformation? So look at this standard looking equation up here and tell me about K. What type of transformation? If we
vertical.
Very good. Vertical. So this is a vertical shift. So put vertical shift. All right. Now, let's say K was a positive number like 3. I plug K in, then wouldn't that be plus 3? Would that go up or down?
Up.
Up.
All right. So if K was positive, so if it was a positive K, then we're going to shift up. And obviously, if it was a negative K, it would shift down. So we reviewed vertical shift. All right. Let's move on. Any questions about that? Any questions about that piece? Now, for example, just in case, if K was negative 3, wouldn't that plus make that a minus 3, right? Plus a negative will be minus 3. So that's why we're going to go down for that one. All right, good. Let's move on to H. Let's move on to H. All right. This is H right here. What type of shifting is that? Type of
Horizontal.
shifting?
Horizontal.
That would be a horizontal shift. Now, let me say this. Let's say this is the standard equation. Minus is already there. If H was 3, if I plug H in and it was 3, for example, it would be inside BK minus 3, right? Would that go, where would that go, left or right?
Right.
Right. But y'all see, I plugged in a positive H, but when I plug it in this standard form, is a minus there. All right, so it's always opposite of what you think it is. All right, so just write, just in case you don't understand what I'm about to write. You know what you're doing. So just in case you don't understand why I wrote it like this. All right, positive H equals shift right. And then if it was a negative number, like H equals -5, if I plugged in a -5, it already has a minus sign, then I plugged in a -5 there, wouldn't it revert to a plus sign right there in the
Yes.
middle? All right, and usually if it's a plus, it goes which direction?
To the left.
The left.
Right, great. So just in case you know what you're doing, just in case you don't understand what I'm about to write right here. All right, so if the H was negative, then what would happen is it shifts left. All right. All right, let's go to something else. All right, I think I heard somebody had a question. Let's see.
Me.
Zoe. Yes.
Okay, so you said positive H shift right?
Yeah, so if I plug in 3, it will still be minus. If H was positive 3, if I plugged in the 3 into this equation, you still would be -3, wouldn't it?
Miss Tom, I
I
think
thought
it's we confused on what you wrote.
yeah, because I thought
Exactly.
if it was a negative, I thought it went to the right. If it was a positive, I
Right.
thought it went to
That's
the
why I
left.
said go with what you learn because you're probably not going to
Oh,
understand what I'm writing right now. I'm saying if the actual H, if we plug in a positive number into into the H right now, it will still be minus that number, right? So you do exactly what you've been taught to do from Tuesday or whenever I first taught it.
okay.
All right, tonight we're gonna get
I
to the
guess I
homework.
would, if I could chime in.
Okay, go ahead.
What I guess appears to help for me is like with the H. If you know if it's a horizontal shift, right? Then look at the
Uh-huh.
sign before, and if it's a negative, you know that your negative numbers are on the left side of the horizontal. You know what I'm saying? The horizontal grid or whatnot, and the positives on the right. That's what kind of helps me uh, tell the distinction
Yeah.
between where it's gonna line up. You get what I'm saying?
You just looking at the H, or what are you looking at?
Right. From
Okay.
the H standpoint.
Okay. Cool. Yep, that works too. All right. Thanks, Kenna. All right, A. Let's look at A. This number right here. What type of transformation did we discuss the last time?
If it like flips over the x-axis or the y-axis.
Okay. Okay.
Like if it was
Good.
a
That's one
negative.
piece. Yep. That's one piece. What else we talked about? Anything else y'all
Oh,
remember?
if it shrink or if it stretch.
Yes. All right. So if for A, it's gonna either be a vertical stretch or shrink. All right. Now, if A is greater than 1, what did we say?
It's gonna be a
It's gonna be a
stretch.
strip.
Yep, it's going to be a stretch. All right. So if the number A is greater than 1, it's going to be a stretch. What if the number was between 0 and 1?
It's gonna be a shrink.
Shrink. And you might see this on the internet. They might say compress. Okay. I'm just going to put the word compress right next to it. You might see that word. All right. And again, you said if it was a negative number, you said it would reflect. All right, if A was negative, what would it reflect over the x-axis or the y-axis?
The X.
The x.
Yep, that is true. The x-axis. All right, we're just gonna do one more. that I just want you to write down, but I'm not really going to, I'm going to go ahead and tell you, I'm probably not going to test you too much on horizontal stretching and shrinking. I'll probably be more so vertical. But I'm going to go ahead and tell you how you know it's horizontal. All right? Because I saw a homework problem that I know was horizontal. All right. That involves B, what's on the inside of that parenthesis or under the radical or is enclosed inside of something. All right. So that's going to be horizontal stretch or shrink. So just write this down. If B is less than 1, it's a stretch. If B is between 0 and 1, it's a shrink or a compress. And you may know this one, though. You may know this one. What if B was negative? What does it reflect over?
The x-axis.
The X.
Now, the A on the outside, if the negative was on the outside, it will reflect on the x-axis.
Should be Y.
It must be Y. If that negative is on the inside of something, it reflects on the y-axis. And we talked about it at the very end of class, so you may have forgotten. So we had an example like this, where we looked at y equals the square root of x, like so, and we said that looks like that, and then y equals negative square root of x, that would reflect where? If it was negative on the outside.
Over the y-axis.
On the outside, see, on the outside. Y'all
Over
see
the
that?
x-axis.
Yeah, it'll be down here. And let me change it again. What if it's a negative on the inside? Y'all see to me the difference? One is on the outside, one is on the inside. The one on the inside is going to go this direction. And you could have both. So you could have this. Y equals negative square root of negative x. That's going to be down here. It's going to reflect on both at the same time. Not only will it reflect down here, it'll flip over the y-axis too. All right. All right. Let's get to some homework problems. All right, Zoe, what's your homework problem?
Okay. I got it pulled up. I just gotta go to that tab. Okay, so it was problem 6. I got the first part right, but the second part I got wrong.
Is it a graph?
Yes, ma'am.
All right, let me.
You want me to tell you what the graph? I can tell you what the graph is, I guess.
Yes, what is it?
Okay. The parent function is going to be the square x squared. F
Okay.
equal x squared. And the first part I got right, it moved down 3 units, so I end up with x squared minus 3. Y equals x squared minus 3.
Okay. Yep, it moved down, so that's x squared minus 3. Okay.
Okay, now this other graph. Okay, so can I share my screen with you? Just share my screen or something?
Yeah,
Okay.
let me pull up. I'm gonna pull up what number is this? So you say
Did I say
what number is this?
6? Number 6.
Number 6.
Yes, ma'am.
Maybe.
I can't explain that one.
Okay. All right, we're gonna help each other out. Okay, y'all, we gotta help Zoe. Okay, yeah, that looks good. X squared minus 3, and then B happened. Okay, what do y'all say about B? I'm trying not to show y'all the answer.
I was lost on B too, so I don't know.
Okay,
It's wrong
It,
what
anyway,
is it?
Dr. Thomas. They can't cheat.
Huh?
It's wrong anyway.
Nah, well, when you all see my side, you see the
Oh,
answer.
okay, no man.
And I want y'all to think about it first
It
before
looked
we
like
decide
it's
on it.
going right to left, so I would say horizontal.
It's
yeah,
a horizontal shift.
Is it
And then
negative
it's
two?
flipped.
Wait,
it'll be a per. Yeah, it would be a negative
All
x
right.
squared.
I got my number 6 right. If you wanted to share my answer.
I don't want to share the answer. I want you to explain it. All right. So somebody said, okay, horizontal shift. Horizontal shift where?
to the left.
To the left. How many units?
Two.
Two? I don't know.
Negative
2.
2.
It's gonna be a positive two, man.
Yep, it's going to be opposite of what you think it is, right? When
Positive
you
two.
write it down.
Oh, yeah.
So it's going to be x plus 2 in what?
Parentheses.
Parentheses.
In
Square.
parentheses,
Um,
square,
no.
okay. Then it wasn't just a horizontal shift. It was what else?
A vertical.
It's
Vertical.
flipped. It's
A vertical shift where?
X.
Up. One.
Up
Up,
1.
Oh,
up 1.
Up.
Would that be plus 1 or minus 1 then when we write it out?
look. I'm gonna do man. I don't know because it flipped.
Yep, it flipped.
Yeah.
So what does that mean? I got to add to the front.
You gotta add a negative to the front of the problem.
Yes. All
And
right.
it's gonna be a plus one.
Yep. Yep. Now, I know if y'all see it right now on the screen, it looks weird because Weber sign is obviously is
Oops, sorry.
a machine, right? That when they calculate it, it might switch around, but you could put negative parenthesis x plus 2 close parenthesis squared plus 1. That's the same thing as what you see on the screen right now. They just flipped it around for whatever reason. It's a machine. It doesn't really know how to write it out. Okay. So negative open parenthesis x plus 2 close parenthesis squared plus 1.
I'm sorry, can you repeat that, Dr. Sunny?
All right, let me write it down. But y'all see where the y is plus 2? Y'all see y is plus 2?
Mm-hmm.
Let me know.
Yes.
All right, that's the horizontal shift. You know it's opposite of what you think it should be. All right. So it's plus 2 because it went left 2 units. All right. It's going to be plus 1 at the very end when you write it out because it was a vertical shift up 1 unit right here. It went up because it was right here and then it went up 1 unit. Then it flipped. So that's why there's a negative in front of the parentheses. All right. So I'm going to write it out. All right. So you probably would have written it f of x equals negative parenthesis x plus 2 squared plus 1. That's the horizontal shift here. This is the vertical shift. And that negative represents reflection over which axis? The negative on the outside represents reflection across which axis?
Why?
It's actually x. So think about it. If you flip something down, aren't you flipping over the x? If you flipped it to the left, then it would have been y-axis. All right. I might have to use some hand motions so to show you what I mean about that.
It is number 20.
All right. So you got, it's just that bare bottom thing there. Okay, so that's g of x equals absolute value of 2x. F of x equals the absolute value of x. And then they wrote it like this. G of x equals f of what? All right. And we're going to talk a little bit about composite functions next week. It's asking what would you plug in to the f function to make it look just like the g. All right, so the f of x is the square root of x. What would you plug in for x? All right, let me write it down. Right. G of x equals f of something. Okay. G of x equals f of something. And we're trying to figure out what goes inside the parentheses to make them look exactly alike. F of something. So we need to figure out that g of x equals the absolute value of 2x. What can I plug into this x right here? What can I plug into, hold on. What can I plug into this x right here so that it looks exactly like this? That's all it really asking. I know it looks weird, but what do we plug in? What do we substitute for x? That's the best way to put it. What do we substitute for x so that it looks like this? X would have to equal what so that it looks just like this?
Is it 2?
2.
2.
All right, so if I plug in 2, I'm going to get this.
Oh, so
Does it
you got
look
to
exactly?
plug in 2x.
Yes. That's it. I know it's strange. I honestly wish they didn't have that piece on the problem, honestly. But it is, and I had to use it. All right. Because I'm not gonna ask you that. All right. I'm more concerned about, you know, when to go left, right, up, down. When you know how to reflect, do you know when it's gonna stretch or shrink? That's what I'm looking for, really. All right. So again, what? Okay. Again, what should we replace the x with so that it looks in the L function so that it looks just like the G function? That's all it's asking. So we want 2x to equal 2x, or replace the x with a 2x so that it looks exactly like that. That's all they're asking. All right, somebody else had a question. Tanaya, didn't you have a question?
I had a question for number 2.
Okay, what is it? What does it say? What does it ask you, number 2?
It said use the graph of f to sketch each graph, and it lists like 6 other problems.
Okay, let me go to yours then. Okay. Number 2. So, okay. So, And if y'all ever don't want me to show your homework, just let me know. We all working on this together though. So don't be embarrassed. This is not your final score or whatever. All right, number 2. Use a graph of F to sketch each graph. All right, so for this one, A, he has enclosed in something. Y'all, which shift is that? Is it
Horizontal.
Horizontal? And well, horizontal, it's opposite of where you think it should go. So horizontal shift where you think?
To the right.
To the right.
To the
Two.
right.
To the right. How many units?
2.
2.
2. All right.
2.
All right, good. Does this look like the first one? Does it look like it shifted to the right from the original?
No.
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 This one right here look like it shifted where?
To the left.
To the left.
Left.
All right. Which one y'all think at the bottom is the right one?
D.
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 All right.
D.
D. You see how it looks like it shifted to the right, Tanaya?
Yes, I got the first one, but I was confused on the other ones.
Okay. All right, this one. All right, there's a +5 like on the outside. It's not on the inside. So what shift is that?
Vertical.
Vertical.
Vertical. So from the original, it's gonna go up or down?
Up.
Up. Okay.
Up.
What about this negative? What do you think that negative on the outside of the function is?
You're gonna reflect over the x-axis.
It's gonna reflect somewhere. Very good. All right. So see how now they gave you all of them actually flipped. So we can't we can't eliminate one from that. But think about this. If it was at like the top was at 5, think about if it went up 5, but it flipped over. So it wouldn't be this first one. Y'all see why it would be the first one? Because it's too far down. Y'all see that? And this one kind of went left. And this one kind of went right. You get that, Tanaya? It was like a vertical shift up, but it had to flip at the same time.
Okay, I see what you were saying.
What about this 1/3 business in front?
It's gonna stretch.
That's right.
It's gonna do what?
Stretch.
You sure?
It's gonna shrink.
I thought
All
it
right.
was straight.
Okay. If the number is between 0 and 1, it's a vertical what? Let's make sure we got it. That's 1/3. That's a number between 0 and 1.
Oh yeah, it's a vertical shrink. That's right.
So does that mean it gets skinnier or it gets a little wider when it's a shrink?
Skinnier.
Linear.
Shrink.
It gets wider.
It gets wider. All right. Again, think about Play-Doh. If you compressed it, shrink or compress, it gets a little wider. If you stretched it, if it was a number greater than 1, and you stretched it vertically, it gets skinnier. All right. So the answer is, in this case, this one over here. All right. It did not reflect. So we could have eliminated this first one right here, and we could have eliminated this one over here. But then we had to decide, does it get skinnier or does it get wider? Does that help, Tanaya, with that one?
Yes, ma'am.
All right. What's another one? Because we got to start on our actual 1.8 today. What else? While I'm on your homework.
I don't think that was the only one because number 3 was the same as number 2.
Okay. Okay. All right. I think I wanted to show you one problem myself. All right. I'm gonna use your problems tonight. I think it was number 9. Because number 9 is a little different. Number 9. All right, let's look at this one. A. Okay, we got the square root of x. We're looking pretty good. Tell me the shifts for A. Tell me the shifts for A.
It had a vertical shift down
Okay.
and then
How
a
many?
horizontal shift to the left.
All right. All right, good. Vertical shift down. So that's why it's -6 on the outside. And then we went horizontal shift to the left 2 units. That's why it's on the inside of the square root, but it's opposite of what you think. So it's, even though we went left, it's +2. Y'all get that? All right. Any questions about A? Okay. I want you, I'm trying not to show you the answer for B. I want you to maybe take a picture of B really quickly, and we're going to discuss B. All right, take a picture with your phone or something. And let's talk about there's a lot going on with that. All right, so I'm gonna stop sharing, give you about 10 more seconds just to take a picture of the screen with your phone or do a screenshot or something. All right, I'm gonna stop sharing and go to the whiteboard because I can't write on that screen. All right, tell me the vertical. I could just do a screenshot of that. Hold on. Kind of want to crop it, but that's all right. All right, here we go. Let's look at B. Y'all tell me what type of transformations are going on with B.
Well, it reflected over the x-axis.
All right. All right, so I know it's f of x equals square root of x, and she's just said it reflected over the x-axis. So where do I put the negative then?
In the
On the
front,
outside.
well, outside of it, yeah.
All right. So we're about to build this graph right now. What else did it do?
It shifted to the right.
All right. So that would mean it would be what on the inside?
A negative.
Tell
Oh
me
wait,
exactly what to put.
Well,
It'll be what? On the inside.
x -4.
On the inside.
Would it be x?
Or negative x -4.
Now, -4, wouldn't that be on the outside? Think about it.
No, it was on the -2 and then it went to, okay, never mind, it flipped. Okay.
Okay. See, there's a lot going on here. Tell me what goes on the inside under the square root symbol. All right. Somebody's saying something. X -2. All right, good. Okay. All right. Now, let me just say this. Let me say this. The original looks like this. Now, if it was just this, it would have done this. Wouldn't it would have done that? But it's not doing that. It's doing this. So what else happened? What else happened?
It's a
a
negative
like
x. That's
It's
two.
negative. Yep. But you gotta put a parenthesis around it before you put that negative. It's a negative on the inside as well, not just the outside. Not only did it reflect across the x, it flipped left too. Not just down, it flipped to the left. So there's a negative on the outside and the inside. So make sure you write this down because you're going to have a similar problem. All right. This could have been written in several ways. It could have been written like this, negative square root of, let's distribute the negative. If we distribute the negative, wouldn't it be negative x? What else? So look at this. Let's distribute the negative.
Plus 1.
Plus
2.
2, right? So I know that looks strange because we think a different way, but this is the same. Or here's another way you might see it written, just in case they flip things around. Negative square root of 2 minus x. Isn't that the same thing too? All these mean the same thing. You may see them write it like this. F of x equals negative 4 minus square root of one of those. So if you see any of these, they all mean the same thing. I just flip things around. And I want you to be familiar with, if they flip it around, what it really means. All right. We're going to let that marinate. And let me just say this. There is a little problem solving form on Blackboard. If y'all want to put questions out there in Blackboard, and it's like a little discussion board, and y'all want to discuss it as a class. Now, I thought y'all also had a